everybody, and welcome to the Homework Helper 4. Zoop, zoop, zoop. Ooh, 8.6. Sweet. The first thing that we're going to start with today is finding percentages, and there's a cute little trick that I'm going to show you in a minute, but we'll go ahead and just do it the hard way. So we know that Mrs. Gonzalez knows that her new chorus class had a lot more girls than boys in it. There were 32 girls and 17 boys. And then it's asked what percentage of the class are girls. And anytime we're looking for percentage, we're looking, look at that sign. It's kind of like a division sign, right? When we write percent, it's kind of like a division sign, which means it's also kind of like a fraction. And so the fraction that we're looking for is we're looking for the part that we're wondering about over the whole. So when it says what percent of the class are girls, we're looking for the part that is girls. So the part is 32. And we're looking for the whole. Well, and the whole will be girls plus boys. So that's going to be 32 plus 17, or 32 over 49. And then from here, I mean that's gonna be what we enter to figure out what our percentage is. So I'll go ahead and pull up my calculator. I'll do 32 divided by 49, and I see that I get 0.6530, blah, 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 blah. So what I'll write here is I'll write 0.653, but then when I want to write this as a percentage, anytime we take a decimal and convert it into a percent, I mean, think about what percent means. You know, even the words per cent is per cent, right? And cent means 100, so per 100. So when I look at this, I have to remember my decimal rules. I know that this is called the 10th place, and this is called the 100th place. So all I have to do is move my decimal over 2 spots so that I get 65.3%. But then I see it says round answers to the nearest percentage. So that means I can drop my decimal in this case if it were, whoops, can't even see it. And I can drop my decimal in this case because it's less than 5. If it were 5 or greater, I would round it up. So this becomes just simply 65%. And a neat little trick, if you're trying to do this in your head, like, 49ths is a hard thing to do in our head, but a neat little trick is that A percent of B is the same as B percent of A. So for example, if I wanted to figure out what 32% of, 61 is, that's the same thing as 61% of 32. You might be thinking, Victor, that's crazy talk. Well, let's find out. So to calculate what 32% of 61 is, what I do, and what I enter in my calculator, is I start with 61, and then what I do is I multiply it by 32%, but in decimal form, so times 0.32. So I take 61, and I go times 0.32, and you see I get 19.52. Now let me try it the other way. I'm going to take 32 and multiply it by 0.61. That's 61% as a decimal. So I'm going to do the same thing. If I do 32 and I multiply that by 0.61, you see I get the exact same answer, 19.52. It's kind of a neat little trick. Not going to be terribly relevant, but sometimes you might be in a stuck point where one is easier to figure out than the other. All right. Let's move that on. Let's go ahead, go to the next section, the set piece. This is kind of like a throwback, where we're talking about graphing exponential equations. So what we're going to start with is we're thinking about the graphs y equals 2x and y equals 2x minus 4, and it wants us to make a prediction. What I want you to think about when we're doing this is remember that whole, h of x equals g of x plus k. And remember what that k did. Whenever we would do that, we would end up with lines that were parallel. However, parallel only works with straight lines. So what's going to happen when we end up with exponential lines that are curved? Well, that k definitely moved us up or down. So I would predict that this minus 4 will cause this to be the same line, except it'll be moved down 4. okay? And then it says use your calculator to graph both equations on the same grid. So it says use your calculator. So what I'm going to tell you guys to use for your calculator, let me show you guys my phone Arena here. Here's my cellular phonic device. And so what I strongly recommend, and actually I should almost require if you have a smartphone, is you get an app that's called Desmos right here. It looks like this. It's also available on the web, DESMOS. But when you open this thing up, let me turn this light off, it's causing a little bit of a glare, Desmos. So this app is a phenomenal free graphing calculator that you can use on your phone. So all that we have to do here is we can just type in all of this. So I have y equals 2x. Go ahead and pause the video and download this right now. So I have y, and then I just have to write equals, and then I have 2 to the x power. So you can see I have that a to the b power, so I'll just do that, and that's where I'm going to put my x. Done. So I have that line. You can see it right there. We have this red line. So now I'm going to add a second equation just by clicking here. So I'm going to say y equals 2 to the x power, and then this time I'm just going to press this right, because I'm kind of stuck in the exponent. If I just hit this right button here, it pulls me back down. And this time I'm going to subtract the 4 I'm supposed to subtract. So subtract 4. And sure enough, I have it. So I can just close this, and you can look at this graph here. And you can see that, yes, it is moved down 4, but when we zoom out, like, it looks like they touch, right? It looks like they come close to touching, but no matter what, whenever we look, we'll see that they never actually touch. We can follow this line all the way up, we're all the way up into the 58s right now, the 60s, 70s. They never actually touch, though it looks like it when we zoom out. So that's kind of a neat little trick. So I strongly recommend getting this app for your phone. It's a great calculator. If you don't want to get it for your phone for whatever reason, it's also available online at desmos.org. Boop. Sweet. So seeing that, we can kind of see what happened here. And then we used our calculator to graph both equations on the same grid, explain what stayed the same and what changed when you subtracted 4. And we can see that like the shape stayed the same, but it just moved down 4. And then it says if you don't have a graphing calculator, you can easily do it by hand, which you could, but we do now, so we'll just use those. All right. And ready, set. Where's the next page? Oh, there's the next page. I lost the next page for a second. There we go. Finally go, we're doing vertical transformations. So pretty much all that it wants us to do is it gives it to us in transformation form, but it wants us to graph it. So if g of x is f of x minus 5, all I know, if this is f of x, I just need to go down 5. So 1, 2, 3, 4, 5. There's 1 point. Where does it cross perfectly? Here. 1, 2, 3, 4, 5. There's another. All right. So where's another one? I just want one more right here. 1, 2, 3, 4, and 5. So here's my line. This is my, see how it's labeled f of x? I'm going to label this g of x. Then it asks what the equation of f of x is, and I can see that it's f of x equals, what do I go? I go down 1, 2, 3 over 1, 2, 3, 4. So negative 3/4, right? Because I go down 3 over 4. So 3/4 x, and then I see that I cross at 3 plus 3. So that means my g of x, I'm going to have the same slope, right? 3/4 x. And sure enough, I can just double check. 1, 2, 3, minus 3, 1, 2, 3, 4, plus 4. But my intercept's different. This time I'm at minus 2. And of course that makes sense, because 3 minus 5 is going to be a negative 2. That's that, woodchucks. We've got a quiz tomorrow. Best of luck to all of you, and study hard.